Hey, hello everyone, and welcome to the demonstration for Zero to CCNA. In this demonstration, I'm going to show you what exactly are you going to achieve once you complete our Zero to CCNA course. So it's not going to be just the technology that I'm going to cover today. Because of the time constraint, we will talk about some of the important technologies, and you will see that there is much more apart from this as well. But just to see exactly that what will you get in this program, I'm going to show you in this video. So let me share my screen and let's get started. So today we are going to cover some of the technologies like in CCNA, you have some important topics like in the switching part, you have VLANs, trunking, VTP, STP, Ether channel. And then on the routing part, you have inter-VLAN routing, static and default routing, OSPF, DSCP configuration, and DNS configuration. So in today's video, we are going to use a topology, something like this, where as you can see that there are two branches, branch 1 and branch 2. And in each branch, we have some departments. Like in branch 1, you have IT department and HR department. So these are actually placed into different VLANs, VLAN 10 and VLAN 20. So that there is only direct communication within the VLAN. And if you want to have communication between VLANs, so basically, if you want to have communication between different departments like IT and HR, then you will have to go to the gateway, which is router 1 here, right? This router here, R1. And you need to go through the gateway, and we can configure some policies on the gateway if you want to secure the communication, like what kind of communication will be allowed and what kind of communication is not allowed, right? So we can actually create security policies as well. Similarly, in branch 2, we have two departments, sales and marketing. So we have placed them into different VLANs, VLAN 30 and VLAN 40. So in branch 1 and branch 2, we are going to understand how to configure VLANs, associate ports, how to configure trunking, how to configure inter-VLAN routing. And after that, between router 1, router 2, and router 3, this middle portion, we will configure routing. So we will use OSPF as the routing protocol so that we can finally have end-to-end communication between computers from IT department to, for example, computers in marketing department. So there should be end-to-end communication. One thing. Second thing you will see is that in case of in case of internet access, we have a connectivity from router 2 toward the ISP, and we will receive the IP address from the internet. And after that, all computers should be able to ping any of the domain names also, like google.com or karotul.com, linkedin.com. So that should also be reachable from our devices. So we are just using routers and switches. We are not actually using computers for the end device clients. But in exams also, like if you go for CCNA or CCNP or CCIE, they generally have just the routers as the end devices as well. Now remember, today's session, don't worry, you don't need to understand everything. You don't need to exactly understand how VLANs work or trunking work or routing work, because I'm just demonstrating you that what exactly you will be able to achieve once you complete our course, right? So that's the important part, that you will see that exactly what you will be able to do once you go through this course. Now, there are many CCNA courses out there, but how this is different is because we are completely hands-on based. So as you can see, we are going to start right from the beginning with the practicals, labs. And if you join our course, you will have labs every week for different topics. So in every week, the session that you will have with me, I'm going to go through the exact explanation how this technology works, what are the important commands, and then I will do the lab right there into the Zoom session, and you will have the recording available with you for lifetime. And during the week, I will send you the labs if you join the program, and then you can actually practice the lab on your own. We will provide you everything. And the setup that you see right now, it's called EVNG, which is a network emulator. Emulator means that you are using the real iOS images, but just that the hardware is not there. We are just using a software interface for that, right? So by the end of this program, when you reach to the end of this program, you will have enough practice to have that comfort level or have that confidence to go for the exam. Because CCNA exam, it's a theoretical exam, it's a multiple choice question exam, and there are only few simulations here and there, a very basic simulation. But the problem is that if you just approach it with a theoretical point of view, you try to understand the concept just by reading it or understanding the concept, but you don't get the confidence to do the configuration, right? So that's exactly what we are going to tackle in Zero to CCNA program, so that every week by week, you will go through the labs and you will make sure that you understand exactly how things will go. And don't worry, if you have any questions, you can leave them into the chat box, because after this presentation, I will open the chat, and then we can have a Q&A session where I can answer your questions into the comment itself, right? So let me go ahead and start configuring this. Again, don't worry if you don't understand how things are working, because this is just a configuration or just a demonstration to show you how exactly or what exactly will you be able to achieve once you complete the program, right? So what we are going to do is we are going to start from layer 2. We will start by creating VLANs and configuring trunking. So in this case, that we need to do on the switches. So like in branch 1, I have 2 switches, switch 1 and switch 2. So both of them need to have VLAN 10 and VLAN 20. Both of them need to have trunking between them. And then we will configure the interfaces which are going toward the computers as part of the VLAN. So VLAN membership need to be there. Ultimately, the end goal is that there should be compartmentalization between different departments, so they cannot communicate directly to each other. Like PC1 can communicate with PC3 because they are from the same VLAN or same department, IT department. Same way, PC2 should be able to communicate with PC4, same department, HR department. But the communication between an IT and HR department should not be possible until unless we configure the inter-VLAN routing, which is enabled by the gateway, right? So this is the interface. You actually connect to the terminal. So I am connected to the terminal. And let's go ahead and configure switch 1 and switch 2 with VLANs and also configuration of trunking, right? So let's start from switch 1. So currently, if we see show VLAN brief, we only have the default VLAN, VLAN 1, which is the broadcast domain, how far the traffic can go before the gateway stops it, right? This is the scope of your broadcasting or unicast communication. So let's create the VLAN. So for VLAN creation, we use VLAN and the VLAN number, and we give it a name. For example, this is the IT VLAN, and similarly VLAN 20, name HR. So 2 VLANs are created. If I check it again, show VLAN brief, now I see 2 new broadcast domains, so 2 new VLANs, right, for each department. But as you can see that there are no associated interfaces. So if you see this portion here, the ports, there are no ports associated with VLAN 10 and 20. Everything is associated with VLAN 1. So we need to move the particular ports to the VLAN 10 and 20. As you can see into the diagram, Ethernet 00 on switch 1 should be in VLAN 10 because it is going to the PC1, which is supposed to be in VLAN 10. And Ethernet 01 should be in VLAN 20. So let's go ahead and do that. So interface Ethernet 0/0, which is going to PC1. And first of all, we make it an access port. So in our course, you will also learn how exactly the difference between access port and trunk port. For example, access port is the one which is member of a single VLAN only. And then we configure switch port access VLAN 10. Right, sorry. Switch port access VLAN 10. And similarly, we need to place interface Ethernet 0/1 into VLAN 20. So switch port mode access and switch port access VLAN 20, right? So now if I show you the configuration that we did, you can see that VLAN 10, E00 is in VLAN 10 and E01 is in VLAN 20. So we need exactly same thing on switch 2 as well. So we can just copy and paste it, because on switch 2 also Ethernet 00 is going to VLAN 10 and 01 is going to VLAN 20. So let's go to switch 2 and create the VLAN. So VLAN 10, name IT, VLAN 20, name HR. And then finally we go to the interface Ethernet 0/0 and switch port mode access to make it an access port, and switch port access VLAN 10. Again, don't worry if you don't know about the concept of VLAN or trunking. This is just a demonstration that what you will be able to do after the course. So this is what you will learn to, if you have a company, if you're part of an organization where you need to plan the VLANs and associate them with different departments, you will be able to do that after this course, right? Similarly, 0/1, this is also switch port mode access, and the switch port access VLAN should be VLAN 20. So now these 2 different ports on both switches are part of different departments. But how do we extend that? Like if I want to go from PC1 to PC3 in the same VLAN, how do I extend it from switch 1 to switch 2? So for that, we need to configure trunking between switch 1 and switch 2. And for trunking, we will use these two ports, E02 and 03. And I'm using two ports to increase the bandwidth, but you will see that spanning tree protocol, which works to prevent loops, that actually it blocks one of the port to prevent any kind of potential looping. And we have a solution for that. We will configure something called ether channel link bundling, so that we can use a logical link which is using both of these physical links, right? But before that, let's configure trunking on these two ports between switch 1 and switch 2. So interface range, we can use interface range command if we have more than one ports, like Ethernet 0/2 and 3. So if I want to configure both ports with the same configuration, I can use the range command. And switch port trunk encapsulation, the protocol that we are using is called .1q, 802.1q. Again, these all things will be covered in the class as well. So switch port mode trunk. So trunking is configured. Now if I show VLAN brief, you can see that we have the membership now, IT and HR, and the correct port is showing as the member of that VLAN. Also, if we check show interface trunk, we can see that we have trunking on the ports going between the switches, right? So the idea is that now we have different broadcast domains for different departments configured on both switches, and the correct ports are associated with it, which is going toward the VLANs. And between the switches, we have configured trunking as well, right? So the Cisco iOS, we are using the EVNG, so you will see that we are using 17.2 Cisco iOS. And later we also include, like if you go for advanced courses, CCNP, CCIE, we also use iOS XE, which has the commands which you need for advanced stuff like DMVP and MPLS configuration and all. But for CCNA level, 17.2 is actually pretty good. You can actually use all the commands which is needed for the CCNA class. All right, so let's see that the trunking is already configured. Let's go ahead and configure trunking on this port also, which will go toward the gateway, because the gateway will be able to enable communication between multiple VLANs. And whenever multiple VLANs are included or are part of a configuration, we need to configure the port as the trunk port if multiple VLANs traffic is going to travel over that port, right? So switch to Ethernet 1/1 should also be a trunk port. So interface switch Ethernet 1/1 and switch port trunk encapsulation .1q and switch port mode trunk, right? So trunking is done. As you can see, VLAN and trunking is configured. Now VTP is a protocol which allows you to configure same VLANs on multiple switches without going to those switches. For example, if you see, I had to create VLAN 10 and 20 on switch 1, and then I again had to create them on switch 2. Think about if you have 50 switches in your organization, that will be a lot of work to keep going to every switch and creating the same VLANs, right? So VTP allows you to copy the VLAN database from one switch to multiple switches. Again, we will go in depth about this also in the course, and this is just a demonstration that you will be able to do this very easily after you complete that that configuration part into the exam or sorry, into the course. So let's go ahead and configure switch 1 as the VTP server. What it means is that I will create many VLANs or delete VLANs on switch 1, and on switch 2 automatically that will appear. It will actually be exactly same in sync with switch 1. So switch 2 will be the client. So if I create few VLANs on switch 1, they will automatically appear on switch 2. And if I delete some VLANs on switch 1, they will be deleted from switch 2 as well. So we can go to switch 1 and configure VTP domain, let's say Karotul, the name of our organization. And this is the server. By default, every VTP switch is a server. So if you say VTP mode server, you can say that it is already a server. We can go to switch 2 and make it a client. So VTP mode client. And we did not configure the VTP name Karotul here, but you will see that it's already showing here. If you see do show VTP status, it has already taken the name Karotul from switch 1. So now if I go to switch 1 and show VLAN brief, currently we have two new VLANs we created, VLAN 10 and 20, apart from the default VLAN 1. Same thing on switch 2. We can see show VLAN brief, and we have VLAN 10 and 20. But now if I go to switch 1 and let's create some dummy VLAN for this purpose. Let's say VLAN 100, name corporate. And now if I see show VLAN brief, I see a new VLAN here, so 100 VLAN 100 corporate. And if I go to switch 2 And I check show VLAN brief here as well. You see that the corporate VLAN comes up here as well automatically. So now you have the switches in sync, and you can do it on 50 switches also, 100 switches also, and you can control everything from 1 or 2 switches which you configured as the VTP server. It's not only just about creating. You can actually go to the you can also delete the VLAN 100, no VLAN 100, and if you go to switch 2, you will see that the VLAN will be gone. So now they are in sync, so you don't need to repeat your work on multiple devices, right? So let's do the same thing for branch 2. Means we will create VLAN 30 and 40 on switch 4 and switch 5. This time let's create VTP first, so that we just need to create VLANs on switch 4, and switch 5 will show the VLANs immediately. And then we'll associate the same ports E00 and E01 to VLAN 30 and VLAN 40 respectively, because they are going to different PCs, right? And finally, the port which is going toward the gateway router 3, we will also configure the VLAN, right? So there also we'll configure the same thing. So let's go ahead and configure the VLANs on switch 4 and switch 5. So on switch 4, first of all, I will configure trunking. So interface range, and we can see that the ports are Ethernet 02 and 03 between the switches. So it will be Ethernet 0/2-3. And the range command allows you to configure multiple ports. So switch port trunk encapsulation .1Q and switch port mode trunk. And because you need the exactly same configuration on switch 5 also, we can do show history to see the history of the commands you typed, and you can just copy this from here because it's exactly same ports, right, on switch 5 as well. So this will save you a lot of time. So we go to the switch 5 and the trunking is configured. Now once the trunking is configured, now I can go to switch 4 and configure it as the VTP servers. So VTP domain Karoto. And this is already the server. So now I can create VLANs. So switch 5, let's configure it as the VTP mode client. And now if anything I do on switch 4, VLAN wise, it will also reflect on switch 5. So for example, VLAN 30, name sales, and VLAN 40, name marketing, right? So on switch 4, we created these VLANs, sales and marketing, and it will show up on switch 5 as well. So we did not create it on switch 5, right? But on switch 5, I can see the sales and marketing already pop up. So that can save you a lot of time. Similarly, the ports which are going toward computers, as we know that interface Ethernet 00, so it should be part of VLAN 30. So switch port access VLAN 30 and 01 should be VLAN 40. Right. So now 2 departments, 2 different commands. Also, let's see if you can see this in the history. Yeah, Ethernet 00 port of VLAN 30, a member of VLAN 30, Ethernet 01 member of VLAN 40. And the good news is that exactly same ports are used on switch 5, Ethernet 00 and 01. So I can just copy and paste on switch 5 and bang, there you go. If you check show VLAN brief, Ethernet 00 and 01, right? VLAN 30 and VLAN 40. So you have configured trunking, VLANs, and VTP on these switches. On switch 4, Ethernet 1/0 should also be trunk going toward the gateway. So let me actually go to switch 4, and the port is Ethernet 1/0. That should also be a trunk port. These 2 commands, right, for trunking .1Q. So you will see that in the course, you will also learn that there are 2 trunking options: ISL, which is the Cisco proprietary inter-switch link, and 802.1Q, or in short, it is called .1Q. But everyone uses only .1Q because it's the open standard. So maybe in your organization, you have some Cisco switches, some Juniper switches, some Alcatel switches, or some Aruba switches, some other company. So it will still work between different organizations as well, right? All right, so the trunking is done. Now, if you see the next point is we want to see how does the STP work in this case. So STP is actually working to prevent loops. So if I go to switch 1, if I check show spanning tree, let's see for VLAN 10, for example. So we can say that this bridge is the root bridge, and all the ports are working fine. They are in forwarding mode. Nothing is blocking. But if you go to switch 2, which is not a root bridge, but show spanning tree VLAN 10, we can see that it is saying that root is this MAC address, which is switch 1 root bridge. And I have a root port, and some ports are blocking. Now, we know that between switch 1 and switch 2, we have Ethernet 02 and 03. One is blocking and one is forwarding. So that's what STP does. STP prevents loops by removing or blocking the redundant links or the backup links. So if you think, okay, I will increase the bandwidth by using multiple links like 02, 03 and all, unfortunately, it's not possible because STP is going to block all of them except one. It will not allow more than one links for the potential looping. So what is the solution here? The solution would be to use Ether channel. Ether channel actually bundle multiple links into a logical port. And for STP, it looks like a single port then. And it says, okay, if you have a single link, then I'm not going to block it, right? So let's go ahead and configure Ether channel between switch 1 and switch 2. So this is also something we will go in detail in the course. So here we can go under the interface range Ethernet 0, 2, and 3, the ports which is connecting switch 1 and switch 2. And we can use the command channel group, let's say 1, and mode active. So we are using active and passive keywords. So these are the LSCP configuration, right? So we can actually copy from here, and on switch 2, it will be mode passive. So active means you are actively negotiating the Ether channel, and passive means you are just accepting the configuration. So once this is done, if I check show Ether channel summary, you will see that the port channel is created, and you will see that it will be enabled or configured soon, right? Because we just did it on switch 1 first, so it suspended it because it thought nothing is configured on the other side. But now, since other side is also configured, you can see port channel came up. So we can see show Ether channel summary, and now we have a port channel, right? Now, if you go to switch 2, earlier you see that one of the port was blocking, but now switch STP will not even see two different ports. It will only see one logical port, the bundle between switch 1 and switch 2. So if we check now, show spanning tree, let's say for VLAN 10, you can see only thing we have is port channel, Ethernet 0203 no longer showing, and it's not blocking. So that way we can actually stop any kind of blocking as well. Apart from this, you will see that in STP, we can also control who will be the root bridge and who will be the non-root bridge. So in this configuration part, what will happen? See, I see a comment about the moving a little bit fast. So the idea is that I'm just showing you what exactly you will be able to do once you complete the CCNA 0 to CCNA course, right? So the configuration that I'm showing today is just to show you the different technologies that we are going to cover. So don't worry, because we are not going into the in-depth of details of what the configuration is. More what we are talking about is what exactly you will be able to do. So more important is the result that you will see, that this is out what we will actually cover, or we will see once we complete this configuration, right? So for STP, let's say switch 1 is the current root bridge and I want to change it to switch 2 for, let's say, VLAN 10. Then you can actually go to switch 2 and reduce its priority. Again, this is something you will learn in the course, that how exactly the priorities work and how we can use it. But currently I can see that both have the same priority, 327768, and adding the VLAN number to it, making it 32778. So you can reduce it to something lower, and that way switch 2 will become the root bridge. So for example, I can say spanning tree, VLAN 10, priority, and let's set it to very low, like 4096. And now for VLAN 10, this switch will become the root bridge. So if I check show spanning tree, VLAN 10, and you can see this bridge is the root bridge, right? So, and the priority is also showing 4096, and you always add the VLAN number to it, like VLAN 10. So 4106 is the overall priority. Lower priority means you have a higher preference and you become the root bridge. So that way you can control who will be the root bridge, and then which port will be blocked eventually in case if the port has to be blocked. So Ether channel and STP is clear. Now let's talk about inter-VLAN routing. So in this case, currently what's happening is that we don't have any IP addresses on the computers, and the computers need to get the IP address from DHCP server. So DHCP server in organizations, they use it to assign IP addresses to the computers so that they can access the network and resources. Now, in our case, you can see that DHCP is here on the router 2. So what we will do is we will configure inter-VLAN routing on router 1 so that it can enable communication between VLAN 10 and VLAN 20. And we are using two different networks for this. Like VLAN 10, we are using 10.1.1 network, or it's a subnet of class A network 10. And for VLAN 20, we are using 20.1.1 for the same purpose, right? So for that, we need to create two sub-interfaces on router 1, and each sub-interface will become the gateway IP for the computers. But the main thing is that we need to configure routing here between router 1 and router 2, so that any DHCP request coming from the computers can be properly sent to the DHCP server, and then the DHCP server can actually assign the IP addresses to all the devices, right? So let's go ahead and configure routing between router 1, 2, and 3. And for the IP addressing between router 1 and 2 and 2 and 3, I have already configured. And all we need to do is to configure OSPF as the routing protocol so that they have the end-to-end reachability, right? So let's go to router 1. And if I check what IP addresses do I have. So I only have the network 12 currently on router 1, right? So let's configure this sub-interfaces as well so that we can cater to our VLANs, Ethernet 00.10 and .20, right? So it will be interface Ethernet 00. First of all, make sure that the main physical interface is enabled, and then we create the sub-interfaces like .n for VLAN 10. So encapsulation .1q 10, and the IP address will be what you see here in the diagram. We will use 10.1.1.1, so the first available IP address from the subnet, right? And similarly, we will do the second sub-interface, interface Ethernet 00.20, and here it will be encapsulation .1q 20, and the IP address will be 20.1.1.1, right? So sub-interfaces are created. Now let's activate OSPF on all these routers or all these interfaces. So I think we checked before as well. What IP addresses do we have? So we have three networks: network 10, network 20, and network 12. So what we can do is we can go to the OSPF and activate OSPF on all these three local networks. So this is also something you will learn that in OSPF or any dynamic routing protocol, we just need to activate this on the local interfaces. But if you configure static routing, you need to mention all the remote networks where you want to go. So static routing is manual, and anytime something changes, you have to manually fix it. In routing protocols, it will be done dynamically, right? So all you do is you activate routing protocol locally, and then it will take care of updating the routing table with the new information by speaking with other OSPF speaking routers, which are called the neighbors, right? So network 10 is area 0. Let's say we are using area 0 here. And network 20, also area 0. And network 12 is also in area 0. So you see that I just mentioned the networks you are member of and activated them into the same area. So in OSPF, you use the concept of area to reduce the amount of database you need to keep, and you don't know anything about the other areas. So that's how you reduce the database size. So we are just using a single area, in this case, area 0. Let's go to router 2 and do the same thing. The show IP interface brief, and we exclude anything unassigned. So we see only the ports where the IP address is assigned. And here we can actually configure or activate OSPF here as well. This port Ethernet 02 is going to internet. So we don't need to activate OSPF toward internet. So all we need is toward these two ports, network 12 and network 23. So we will need it on network 12, area 0, and network 23. So if everything is fine, you should see a neighborship should come up between router 1 and router 2. You can see neighborship is up, loading to full. That means that's great. That's all working good. And on router 3, here also we need to create some sub interfaces for router on a stick toward our branch 2, right? So we will need Ethernet 01, .30 and .40. So let's create that. Excuse me. First of all, activate or no shutdown the physical port, and then sorry, not .10, .30 and 40, right? So IP encapsulation first. So we need to associate this with the VLAN 30 with this command, and then the IP address. So 30.1.1.1, and similarly, .40 will be encapsulation 40.1.1.q40 to associate this with VLAN 40, and the IP address will be 40.1.1.1. Now, since this is done, you can activate OSPF on all the interfaces where we have IP address. So router OSPF 1, and here we are going to use the network 23, area 0, network 30, area 0, and network 40. And as you can see that neighborship between router 2 and 3 also came up. So what just happened is that we configured OSPF between router 1 and 2, and we configured OSPF between router 2 and 3. So you always configure neighborship to the directly connected router. So router 2 has 2 neighbors, router 1 and router 3. But router 1 has only 1 neighbor, router 2, because it's only the directly connected router. Router 1 and router 3 will not become neighbor because they are not directly connected. But all the information will be exchanged thanks to OSPF update packets. So router 1 will inform router 2, hey, I know about network 10, 20, and network 12. These are my local networks. And router 2 will say, hey, I know about network 12, 23, these 2 networks. And router 3 will say, I know about network 30, 40, and 23. So after some time, everyone will know about every network thanks to OSPF. So for example, if I go to router 1, I should be able to see network 23, which is actually between router 2 and 3. The router 1 should not know about it by default. And network 30 and 40 as well, 30.1.1 and 40.1.1. That also router 1 will find out thanks to OSPF. And vice versa. You can go to other routers and check as well. But let's go to router 1 and check this. If I check show IP route OSPF, what did I learn from OSPF? So you can see I know about the network 23, network 30, and network 40. That means the networks which are coming from other areas, right? Or other, all good, right? So this one, let's go ahead and check if we can ping. So if I go and ping 30.1.1.1 or 40.1.1.1, you can see I can ping from router 1. So the reachability is already there. That means I can also ping router 2. So now we can configure router 2 as the DHCP server, so that finally we can have some IP addressing on the computers, right? So I'm going to create 4 pools for DHCP on router 2. 1 pool for VLAN 10, 1 for VLAN 20, 1 for VLAN 30, and 1 for VLAN 40, right? So we will need 4 pools here. Let's go to router 2. So IP DHCP. First of all, you always exclude the addresses which you don't want to assign. So exclude address should be at least your gateway IP address should be excluded. But I'm going to exclude the first 100 IP addresses in case if we want to if we want to use it on some manual servers, right? So for 10 network, I want to exclude from 10.1.1 to 10.1.100. So the client should only be assigned from 10.1.1.101, right? So let's do the same thing for network 20, network 30, and network 40. So for all 4 VLANs, we excluded some addresses first, and now we will actually configure the pools. Yeah, that's right. So basically, what's happening is I see some comments about the speed. So don't worry. See, the idea is that we want to show you exactly what you will be able to do once you complete the course, so that you can see the result. So the result is more important, exactly what you will be able to achieve once you do this. Because whatever you are seeing right now, we are going to go very slowly and very in depth when we start the course. So today's objective is not to teach you so many technologies, right? It's not even possible to teach you all these technologies in a single day. It actually takes many weeks, and we deliberately take many weeks so that you get your time, you get the whole week. For example, we cover VLANs. So I explain everything about the VLAN in the session very slowly, and then I do the lab in front of you. So you see exactly how to do it. And then you keep that recording for lifetime. So you can go through that recording again and again. And I send you the lab, and I also provide you the software that we are using so that you can do it on your own time as well, right? And you are ready and very comfortable for the next topic to start. So that's how we will go into the class. Today is just to show you exactly what will be the outcome of this, that you will have VLANs, trunking configured. Ultimately, computers should get the IP address from the DHCP server, which is the amalgamation of switching, routing, DHCP configuration, and ultimately pinging end to end. So that's the objective, and to see how exactly this has to be done. But don't worry, when you actually join the course, it is not going to be fast, because I'm not going to try to show you the result. I want to make sure that you understand the technology when it comes to teaching, right? So that's why it is going fast. Don't worry about don't worry about exactly the commands, because this is something you will learn in detail when it comes to that part as well. So right now I want to create some pool to assign IP addresses. So for that we use the command IP DSCP pool. Let's say pool 1, or let's call it V30 for V10 for VLAN 10. And the network we are going to use for this is 10.1.1.0. Subnet mask is /24. Default router means the gateway is the router 1 IP 10.1.1.1, and the DNS server should be router 2. So I can say 12.0.0.2 is your DNS server, which is the IP address of router, right? So we can actually do the same thing for other pools as well. So let's just copy this, and we can actually do an IP to V20. And for V20, the network will be 20.1.1. The default router will be 20.1.1.1. And the DNS server will be same, right? DNS server is your router 2, which is going to provide name to IP resolution. So that is going to be same in all pools, right? So it is just the repetition for other two as well. So pool B30, and this will be network 30. Default router will be 30.1.1.1. The router gateway IP address, and the DNS server is same, right? Finally, pool V40 is network 40, and default router is 40.1.1.1, and the DNS server is same 12.0.0.2, which is router 2. So you can see now router 2 is ready to provide IP addresses or assign IP addresses. But when the computers will request the IP address, it needs to go through the gateways, which is router 1 and router 3. So we need to configure them as the relay agent. So they can relay the DHCP request all the way to router 2. So we need to configure the helper address command on router 1 and router 3. That who is the DHCP server? Router 2 is the DHCP server, right? So for example, on router 1, on the interfaces which are facing the VLANs, which is interface 00.10 and .20, we need to use the command IP helper address and the IP address of router 2. This is your DHCP server basically. And similarly for .20, the helper address is router 2, right? Similarly, you will do on router 3 for the interfaces which are facing the VLANs, which is Ethernet 01.30 and 01.40. You need to tell who is the DHCP server. So DHCP server is router 2, 12.0.0.2, and similarly for 40, also 12.0.0.2. Now, the gateways are also ready to send the request to router 2 if the computers will send the request to receive the IP address. So finally, we need to go to the computers and configure them to request the IP from a DHCP server, means the IP address DHCP command on the PCs. So let's say if I go to PC 1, and every PC you can see, we are using the port Ethernet 0/0, right? So if I check show run interface Ethernet 00, there is no IP address right now, and the port is shut down. So what I need to do is I need to go to the interface Ethernet 00. First of all, I need to activate this port, and then IP address DHCP. Right. So if I show you the configuration now, you see that I have the command IP address DHCP, means go and take from DHCP, and the port is unshut. So now the request will go from the computer to the router 1, and router 1 is configured already with the helper address command. So router 1 will send the request to router 2, and router 2 will actually assign the IP addresses or IP address to the PC, right? So you can see that PC1 already received an IP address 10.1.100 from DHCP. So if I check show IP interface brief, I have the IP 10.1.1.101. So let's quickly do this on other PCs as well, like PC2. So we need to do it here, interface Ethernet 00, no shutdown, and IP address DHCP. Just 3 commands, right? Basically, interface, no shutdown, and IP address DHCP. So we can actually copy this and paste on every other PC also. So PC3, same thing, and PC4. P5, PC6, basically just requesting the IP from the DHCP server. Finally, PC8. So if you see on PC1, it had received 10.11.101. If you go to PC2, it has received 20.11.101. And PC3 again in the network 10, because PC1 and PC3 are in VLAN 10, and PC4 again in network 20. And similarly, PC5 got in network 30, PC6 got in network 40. So you must be thinking right now that how does the DHCP server know which pool the IP to assign from? Because you see that on router 2, which is the DHCP server, I created 4 pools for network 10, network 20, network 30, and network 40. So how does it know that for PC1 and PC3, I should assign from network pool 10, pool for network 10. And if PC2 comes to me, I should assign from the pool for VLAN 20. And if PC6 or 7 come, PC6 come, I should assign from VLAN 40. But PC5 should VLAN 30. So how does it differentiate between them? So that's the magic of the gateway. What this gateway does, it actually checks that the request is coming on which subinterface. So when PC1 sends a request, the switch is going to tag it with VLAN 10, right? Because the PC1 is in VLAN 10. So when the frame reaches to the router 1, which is the gateway, it reaches there with the tag VLAN 10. So what it does is, when it sends the request further to router 2, it actually includes its own IP address in VLAN 10. So in router 1, the IP address in VLAN 10 is 10.11. This is called the gateway IP address, right? So router 2 receives a request from a computer which doesn't have IP address, but it also receives the gateway IP address, which is 10.1.1.1. So it says, okay, so I need to assign the IP address from the pool for network 10, right? Exactly. So apparently this is called the gateway router, and router 2 will actually see that which gateway IP the request is coming from. Similarly, if PC2 sends a request, switch is going to tag it with VLAN 20. So router 1 will know that, okay, I need to send the gateway IP 21.1.1 because the tag is VLAN 20, and my IP associated with VLAN 20 is 21.1.1. And that's how DHCP server will know, okay, I need to assign the IP from the pool VLAN 20, right? So that's how it is going to work. Now, router 2 already has connectivity to internet, and we have received the DNS server IP also on PC, right? Because in the pool, if you see on router 2, we have created configured DNS server as well. So let's see if the computers can directly access internet or not, right? So currently, if I check my routing table, automatically you will see that it says my gateway is 10.1.1. I need to go to my gateway. And who told me about my gateway? Who told me about my gateway? It is the DNS server, right? So I'm going to go ahead and ping, let's say, first of all, do I have a connectivity end to end? Because we also have OSPF configured, right? So if I try to go, let's say, from, let me make it slightly bigger. Let's say if I'm trying to go from PC1, which is 10.1 something, to PC8, which is completely different zone, branch 2, and different VLAN. So let's see what is the IP of PC8. So PC8 has received 40.11.102. So let's see if I can ping from PC1 all the way to PC8. So 40.11.102, right? Yep, you can see the ping is successful. Let's do a trace route. Trace route means it will show you all the hops, all layer 3 devices in the pathway, right? So let's say if I do 40.1.1.102, and I want to do a numeric one, I don't want to change it to the names. So you see, I'm actually crossing 4 hops or 4 layer 3 devices before I reach to this network. So first device is my gateway, router 1. Then I go to the DHCP server, router 2. Then I go to router 3. And then finally, I go to the PC, which makes sense, right? Because from PC1, the first layer 3 device is router 1, then router 2. Then we go to router 3. And then the last layer 3 device is the PC itself. So that's why it is showing you 4 hops or 4 layer 3 devices are there in the middle. But do we also have connectivity to internet? Let's try to see that. If I ping, let's say somewhere on internet like 8.8.8.8, it is the Google DNS server. So currently I see that I'm receiving unreachable. So let's see why it's stopping it here. So if I do a trace route to 8.8.8.8, and let's do a numeric one. So we can see that we are going to the 10.1.1.1, but that's where it stops. So why is it happening? Because route PC1 has a default gateway, which is router 1. So for everything, it will send the traffic to router 1. So that's good. PC1 is sending the traffic for even for 88888, it is sending it to router 1. But does router 1 have a route to 8.8.8.8, or does it know that I need to send it to router 2 to go to the internet? Because all we have is OSPF, right? And OSPF is for internal networks, not for internet. So if I go to router 1, let's see the routing table. So router is just as good as its routing table, right? So if I check show IP route, I don't see any of the 888 network. Of course, because on internet, there are millions and millions of networks. I simply cannot have all of them here. So instead, what I use a default route. So what I can do is I can configure a default route on router 1 saying that for anything unknown, which I don't know about, I will just throw the traffic to router 2. I'll throw the packets to router 2, and then my duty is done. So let's do that. If I go to router 1, I create a default route, IP route 00000000. When you use 0 means catch all. So anywhere which I don't have a specific route, anything unknown, I will just throw the traffic to this direction toward router 2, which is 12.0.0.2, right? Now, if I check my routing table, show IP route, I do have a 00 route, which is called the default route. You can see this is called the candidate default route. And I will just throw the traffic to 12.0.0.2. So if somebody comes to me to go to 30.11 network, I have a specific route thanks to OSPF. But if somebody comes for 8.8.8.8, which is Google, I absolutely don't have a route. So it will fall back to the default route. Then anyway, I'm going to throw that traffic toward router 2. And what router 2 will do, if you go to router 2, it is getting an IP from the internet. So if you check show IP route, it already has a default route toward the internet gateway, the ISP. So we are already sending traffic to the internet service provider. So now it should work. If I go to PC1 again and try to ping, voila, we have the connectivity to internet, right? And similarly, we have a DNS server. So hopefully we should also be able to use the names. Like if I do a ping www.google.com, yep, you can see, first of all, we go to the domain server, DNS server 12.0.0.2. We change google.com to this IP. We find the public IP of the google.com and we are pinging that IP address, right? And you can actually try this with everything. Let's say linkedin.com, for example, or karotul.com, which is our website. Everything is perfectly working fine, right? And similarly, if you go to, let's say, PC 5678, which is in branch 2, currently you will not be able to do it because, again, same thing, router 3 doesn't know how to go to unknown locations. We need another default route on router 3, again pointing to the router 2, because router 2 is the gateway to the internet, right? So if you go to router 3, and currently I check show IP route, you can see I don't know how to go to unknown locations. So let's go ahead and configure IP route to the unknown location 0000. Next hop is 23.0.0.1, which is the IP of router 2. Now, if I check routing table again, yep, there is connectivity now. So now if I go to, let's say, PC7 is here. So ping google.com. Yep, all good. And what if I ping 10.11.101, which is all the way to PC1? Yep, all good. So we have end-to-end reachability and we have internet connectivity as well. So again, this demonstration was not to teach you anything, because teaching, of course, will require me to explain you everything in detail, and then I will do the lab, and then you will be able to do the lab. So for example, if I just show you one example here, we have some labs. For example, there is a VLAN and trunking lab that you will do in the course, where I'll tell you exactly what to do, which topology to open, and what exactly needs to be configured, and what is the requirement, like configure switch 1 and switch 2 access ports going to the PC in correct VLAN as per diagram. These kind of instructions will be there. So I will be solving this lab after explaining you the concept in the class. So you will have that recording for lifetime access. But apart from that, when I send you this lab, I will also send you the solution file. So if I go to the inter-VLAN or VLAN trunking solution, you will see that I will exactly show you what you need to configure to get this result. Because ultimately, we are not testing you. We are not trying to see how much you know or how much do you recall or retain from the classes. We want to make sure that whatever you learn into the classes, you reinforce that when you are doing it. So we actually encourage you to look at the solution file as much as you want, and make sure you become very, very comfortable when you're doing these things, right? So that's the basic idea. So that's the end of the presentation, the basic introduction that what exactly you will get. So now you can actually ask me if you have any questions.